Ubendra from Sri Venkateshwara College of Engineering. So today's course is gonna be about TOC, that is Theory of Computation, and the research paper I'm gonna talk is about optimizing over serial dictatorship. It's a type of algorithm which we'll be discussing in the further slides. So let's first see what is the about section. What is this about? So the title is, as we know, optimizing over serial dictatorships. So the authors are Yanis Karaganis and Nidhi Rathi. So published inside the Journal of Theory of Computing System. Overview: a study focusing on optimizing agent decision-making sequences to improve outcomes in combinatorial optimization problems. So when this report was published on 3rd October 2024, this research paper. Introduction. So what is serial dictatorship? An algorithm where agents act in a predetermined order, choosing the most favorable action available at their turn. Study goal: evaluate how effective sequences can be computed to achieve near optimal social welfare using a limited number of queries. Application of this algorithm or serial dictatorship. Application is mechanisms used in various social choice and allocation problems like house allocation or voting. So in voting, it is necessary to know who voted for whom, and there is no duplicate votes, etc. like that. The problem overview. Motivation: the simplicity of serial dictatorship makes it appealing for decision making, but it may not always yield optimal outcomes. Optimal in the sense where we get a finite output, or better best solution. Feasible and best solution is known as optimal outcome. So in this algorithm, we may always not yield an optical outcomes. Challenge: finding a sequence of agents that maximizes total value while keeping query cost low. Objective: develop efficient algorithms to improve the effectiveness of SD. Serial dictatorship. Serial dictatorship mechanism. Definition: agents act one by one, choosing action based on their preferences and what remains available. Example: house allocation. Agents pick houses based on a predefined sequence. That is, the sequence is predefined, and an agent picks a house inside the predefined sequence. Drawback: orderings can lead to inefficiency where early agents block choices that would have benefited later agents. That is, if an agent has taken a house early on without browsing any further agents, he may, like, it blocks other choices which may be benefited for him in the further, like this. Formal problem definitions. Optimal sequence problem. Input: agents with valuation function that depend on sequences of previous actions. Output: action sequence that yield high social welfare with limited queries. Monacity assumption: valuation increase when agents have more options. Valuation of a particular object increases when agents have more options. That is, if more options are present, he may look for a better choice than going for the certain available choice. Query complexity and approximation ratios. Query complexity. The goal is to minimize the number of value queries made to agents while ensuring good results. That is, shortlist the more attractive offers or anything while looking for a house. That is, ensuring good results. Approximation ratio, a measure of how close the achieved social welfare is to the optimal solution. So what is like how close we are to reaching the optimal solution. Specific valuation structures. Bipartite matchings assign items to agents, ensuring optimal pairings in a bipartite graph using serial dictatorship. Orborsines in graphs. Agents choose edges to connect nodes, maintaining a directed acyclic structure. Satisfiability of Boolean expressions. Assign values to variables to maximize the number of satisfied clauses. Next, algorithmic approaches. Deterministic algorithm and randomized algorithm. Deterministic algorithm considers all combination of agents, insets and finds the sequence that maximizes collective value. As I told in all the combinations of agents, it finds a sequence that maximizes the collective value, that is optimal value. Whichever is optimal, it finds that. Next, randomized algorithm randomly selects subset of agents and sequences to find the highest social welfare in an efficient manner. So it randomly picks a spot and then searches from that part on or before that part. Monotone valuations and algorithms. Monotone valuation. If adding more options for an agent never decreases their value, the valuation is monotone. Deterministic and randomized algorithms both leverage monotonicity to achieve approximate optimality with polynomial mini queries. Next, special case algorithms, bipartite matchings. Present two approximation algorithms that optimizes assignments between agents and items. Arborescensis focuses on finding directed acyclic graphs with a good approximation ratio. The price of serial dictatorship definition. The POSD quantifies the difference between the best solution a serial dictatorship can find and the true optimal solution. Findings. For some problems, POSD is close to 1, meaning that a serial dictatorship can find nearly optimal solution in these cases. Truthfulness and VCG payments. Truthful mechanisms. Algorithms where agents have no incentive to misreport their preferences. VCG payments. A payment scheme that ensures truthful reporting, making certain algorithms more effective. Example. Implementing a truthful solution for combinatorial optimization through VCG payments. Open world problems and future directions for serial dictatorship. Challenges are improving the approximation ratio for different combinatorial problems. Opportunities are extending algorithms to more complex problems like multi-objective optimization. Potential research, examining new methods for handling non-monotone valuation efficiently. Practical implications, application area. Benefits, application area are the house allocation, resource management, job scheduling and network optimizations. Benefits, the study highlights that effectiveness of serial dictatorship based algorithms due to the simplicity, transparency and truthfulness in strategic settings. We are at the end of this slide, that is conclusion. The summary is this study presents efficient algorithms for improving serial dictatorship mechanisms in combinatorial optimization. Key takeaway in this presentation is near optimal solutions can be achieved using polynomial query complexity. That is only near, that we can't achieve a full proof optimal solution. It can be a near optimal solution, can be achieved. Future outlook. Focus on extending the framework to additional combinatorial settings and improving current algorithms approximation bounds. So this is the end of the slide and thank you all for watching. So before we leave, I would like to show you which and where I have taken the research paper. So this is the research paper I have referred for to make this presentation. So you can see it, and this was taken from Springer. It is available in the website where we go through first we go to Theory of Computing Systems journal. Inside that this research paper is present. So thank you all for watching. We'll meet in the next video. Thank you. Signing off.